Ladies and gentlemen, you are all welcome to my YouTube channel. Today we are going to look at physics. So specifically in these videos, we are going to solve some questions from post UTME and JAMB. So now we are going to look at these questions. The question says, how much heat is given out when a lump of aluminum mass 200 gram and specific heat capacity 880 joule per kilogram for degrees centigrade cooled from 40 degrees centigrade to 20 degrees centigrade. Option A, 5411 joule. Option B, 6513 joule. And option C is 740 joule. And option D is 81 joule. So I think clearly you can see from the questions here, the questions came from specific heat capacity. So we need to understand the concept of specific heat capacity first before we solve the question. Specific heat capacity, and of course, even from this, before the specific heat capacity, we need to understand the heat itself. What is a heat? A heat is a form of energy that transfer due to energy differences. So whenever we say heat, it means that it's a form of energy. We have different form of energy, and of course, heat is one of the form of energy, and we usually have heat when there's a temperature difference. So whenever there's a temperature difference, we have heat. Like for example, let's say we have our initial temperature. Let's use theta as to represent temperature. So if we have theta 1, let's say theta 1 is 20 degrees centigrade, and we have our theta 2, let's say, is 40 degrees centigrade. So this is temperature, but how are we going to get heat? We are going to get heat by taking the differences between theta 2 and theta 1, which is 40 minus 20, and we have 20. So whenever there is a temperature differences, so we have heat. So heat is a form of energy. And of course, we have some basic differences between heat and temperature. Heat, of course, is a scalar quantity, and temperature is a vector quantity. And heat is measured. We use calorimeter to measure heat. We use calorimeter. Calorimeter can be used to measure it, while temperature is measured using thermometer. And of course, in addition to that, the SI unit for temperature is either degree centigrade, degree Fahrenheit, or Kelvin, while heat is measured in joule. So the SI unit of heat is joule. So now, and we have different methods of heat transfer. As we said, heat is a form of energy that transfers due to energy differences, due to temperature differences. And of course, we have different forms of heat. And what are the forms of heat? So we have different methods of heat transfer. We have conduction, we have convection, and we have convection, and we also have radiation. So the conduction, which is one of the heat transfer, is usually found, or the transfer usually exists in solid substances. This one in liquids, this one in gas. So these are actually the form of, or the differences of the different method of heat transfer. So now we are going to look at the specific heat capacity. But before we define specific heat capacity, we have heat capacity. What is heat capacity? Heat capacity is defined as the amount of heat. It's defined as the amount of heat. So now, what is heat capacity? Heat capacity is defined as the amount of heat or amount of energy required to raise the temperature of an object by 1 degree centigrade. Is the amount of energy that is required to rise the temperature of any matter, or any substance, by 1 degree centigrade, So specific heat capacity is the amount of heat that is required, or amount of energy that is required to rise the temperature of an object or of a substance by 1 degree centigrade. And of course, heat capacity is represented with capital letter C and is measured, so the formula for calculating it is Q all over, let's use capital letter Q, is Q all over change in temperature. So Q all over change in temperature is specific heat, is the heat capacity. So the amount of heat or the amount of energy that is required to rise the temperature of an object by 1 degree centigrade is called heat capacity, and the formula is Q all over delta theta. So that is why, of course, we know that the quantity of heat is measured in joule, and then the temperature is in degree centigrade. So that is why it's measured in joule per degree centigrade or joule per Kelvin. So that is the SI unit for heat capacity. But in the case of specific heat capacity, is actually the amount of heat or the amount of energy that is required to rise the temperature of 1 kilogram of a substance by 1 degree centigrade. So that is why this one is called specific heat capacity. Why is it that it is specific heat capacity? Because the mass of an object is specified as 1 kilogram. So it means that in the case of specific heat capacity, is the amount of heat that is required to increase the temperature of 1 kilogram of an object by 1 degree centigrade. That is specific heat capacity. And there is a formula for also calculating this specific heat capacity. The formula for calculating specific heat capacity is small letter c is equal to delta, or is equal to Q all over delta M mass times delta theta or delta T. And this delta T represents change in temperature. So that is why sometimes you can see specific capacity as Q is equal to MC delta T. So M here stands for mass, and C here stands for specific capacity, and T here stands for temperature. And of course, the specific heat capacity of any substance varies. The specific capacity of water is different from that of aluminium. The specific capacity of aluminium is different from the specific heat capacity of copper. So it means that the specific heat capacity of an object varies, is differ from one another. It depends on the types of an object. So therefore, now we are going to solve this question. And how are we going to solve this question? So the question says, how much heat is given when a lump of aluminium of mass 200 grams and specific heat capacity of 880 joule per kilogram per degree centigrade cooled from 60 degrees centigrade to 20 degrees centigrade. So I think it's simple to solve this question. So how to take our data? We have to take our data from the question. So number one, we have mass. The mass is given as 200 grams, and of course the change in temperature, which is T1, is 60 Okay, yes, it turns from 60 degrees centigrade to 20 degree centigrade. It turns from 60 degrees centigrade to 20 degree centigrade. So our T1 is 60 degrees centigrade and our T2 is 20 degrees centigrade. And of course, the specific capacity is already given as C. Is already given as C is equal to 880 is equal to 880 joule per kilogram per degree centigrade. So now what we are going to do, this math is given in gram, so we have to convert it to kilogram. And how are we going to convert it to kilogram? Is by dividing it by 1000. So if you divide this by 1000, you are going to have 0.2 kilograms. So now we are going to, of course, from the question it said how much heat. So it means that Q is unknown. Q is unknown. So our Q now is equal to MC delta T. And we have our Q, which is unknown, and we have our mass 0.2, and we have the heat capacity, which is 880, and then we have change in temperature, which is theta 2 minus theta 1. So we have 20 minus 60 degrees centigrade. So now we have our temperature is equal to 0.2 times 880 times. So our temperature is going to be minus, it's going to be negative since it's changed from 20 to 60. So we have minus 40.